Hello, today I want to look at a three-dimensional trigonometry problem. So how we can use our understanding of the trig ratios of SOH, and TOA, or sine, cosine and tangent of an angle in a right angle triangle to solve a problem in 3 dimensions like this one here. If you do not understand SOH or TOA or right angle trigonometry yet, and you haven't done that, you're going to struggle. You need to understand that first. So I want us to look at a problem like this. The image below is of a cuboid. Calculate the size of the angle between CE and EFGH. It's a lot of information. I cannot possibly answer a question like this without drawing all over that diagram. So that's exactly what I'm going to do. Made it a little bit bigger here, so it's a little bit blurry. But the question is asking me for the angle between the line CE, so I'm going to draw that line on there, and then this EF, G and H, which I think is this rectangle on the bottom, EFGH. That seems to go around and create that rectangle on the bottom. The angle between line CE and EFGH then is kind of the angle between these two lines. Look, the reason that I've drawn that as a diagonal is because it allows me to create a right angled triangle and therefore use my understanding of sin, cos and tan. Once I've got a right angle triangle on the 3-dimensional diagram, I should mark up the angle that I'm interested in, which is this angle between C and E, and then that cuboid at the, that rectangle at the bottom. And then it's a good idea to create a 2-dimensional representation of this right angle triangle and then move forwards and use sin, cos or tan depending on what the question demands. So I draw that right angled triangle as usual over there, and then I'm going to try and put as much information as I possibly can on that. I know that this is the angle I'm interested in. I know that the side length that is opposite that is 11 centimeters. I've taken that from the diagram. This base of the triangle though on the bottom I can figure out because there's another right angle triangle on the bottom of that cuboid. If you look at the base of that cuboid, you've got 3 centimeters, 4 centimeters, and then you've got our base cutting across that. That would create another right angle triangle, and therefore it follows the rules of Pythagoras' theorem. So I know that the base squared is equal to 3 squared plus 4 squared. I can work that out. 3 squared is 9, 4 squared is 16. Add those together, I get 25. So I know that the base length is the square root of 25. That's just a little bit of Pythagoras. If that's confused you, then you might just want to go back and check out some Pythagoras questions very quickly. And the square root of 25 is 5. So I know now that this angle this side length that's kind of adjacent to my angle is 5 centimeters. Now I've got that diagram sorted, I'm going to use sin, cos or tan. So I've drawn that diagram out again. Ignore that green circle, that'll make sense in a minute. I've got 11 centimeter side, a 5 centimeter side, and that is the angle in question. It's probably worth labeling that up. A lot of questions involving trigonometry will label an angle up using this Greek letter. It is theta. So I'm going to use that. You could use any letter you wanted there, really. It wouldn't actually matter. Now I'm going to think about what these sides represent. Well, this 11 centimeter side is opposite that angle. This 5 centimeter side is adjacent to that angle. Remember, adjacent just kind of means next to. We've also got a hypotenuse in that triangle, but I'm not interested in it for this question. I don't think I need it. So I start thinking, do I need to use SOH, or TOA? Well, spoiler alert, that's been there on the whole time, that green circle. It's TOA. And the reason for it is this. I'm interested in the opposite and the adjacent. They're the 2 sides that I've got, so they're the 2 sides I want to use. So I want to use O and A. That means, that dictates that I have to use tan. That's the trig ratio that I'm interested in for this question to figure out the angle theta. So tan of theta is going to be equal to opposite over adjacent. Remember, that's how we say it. SOH, TOA, because it's in that order. TOA, opposite is always on top for tan. So tan of theta is equal to the opposite over the adjacent. The opposite is 11 and the adjacent side is 5. So tan of theta is worth 11 over 5. And then you have to remember how to undo tan of an angle. The inverse of tan is tan to the minus 1. So I know that theta is going to be tan to the minus 1 of 5 over 11. And if I work that out, put it into my calculator, I get 65.556 and so on and so on. I should probably just round that to 66 degrees.